Group 10, Lab 1.
Hi, I'm Sadun Perera.
Hi, I'm Khiren Menon.
I'm Ahsan Saleem. Part 1 of our lab where we have to prove how the equipment works. This is the truth table, this is the Boolean equations, and we'll be doing the schematic for circuit 1. The IC we are working with is 74HC02. This is the output LED, and these are the two inputs. Basically, when we can look at the truth table, we see when the output is when the input is 0 0, we get the output as 0 as well. Whereas when I press A, we get an output over there, and when I press B, I get an output as well. And when we press both of them, we see that it lights up as well. So that proves that the truth table verifies our output.
This is the schematic circuit for number 2. Okay, so the whole thing is an exclusive OR gate, so which consists of 2 NOR gate and 3 NAND gates. Okay, this is the truth table, this is the Boolean equation. So as you can see, we are going to calculate for Y. Okay, so when when the connection is 0 0, it's off, and when the connection is 0 1, it's on, and when the connection is 1 0, it's on. Okay, so when 1 1 is off. It's off.
Alright, so this is part 3 of lab 1, and as you can see, according to these calculations, we discovered that the resistor is 120 ohms. And so we had a 120 ohm resistor, and then we connected it into this circuit that's operating with a NAND gate. We connected this LED here, and if the switch was to be turned on, then it should light up to indicate the circuit is connected correctly. Can you cut it or? Alright, so this is the calculations for part 4. We've managed to construct the Kano map here, and from this we created the truth table, in which you can see only when there are 2 or more positive values does it return a positive. This is the schematic for the 3-bit majority detector. As you can see, we require 1 triple input NAND gate and 3 double input NAND gates. If you look over here, this is our constructed circuit. This LED will light up when it returns a positive value, and these are the 3 switches that we have for inputs. So if you ever press a single one of them, it'll never return a positive value. However, if you were to press 2 of them at the same time, then it is to return a positive value, or all 3 at the same time as well.
See, we're working with over here is 74HC00N. We provided it an input signal of 500 kilohertz. Basically, channel 1 is our input and channel 2 will be our output. Over here we see that the objective is to measure the propagation delay. This is channel 1 and this is channel 2. So the difference we're supposed to measure is from this point to this point, from comparing channel 1 to channel 2. So as you can see, there is a slight delay, and that's what we're measuring, and that's what we'll be calculating further. So coming here, you can see the Alright, so basically this is the TPLH value, which means low to high. So this is the time which it takes to go from low to high, 24 nanoseconds, and this is TPHL, which is high to low. So this is the amount of time it takes for it to go from a high signal to a low signal. So basically what it means is that this is low to high point, and then this is high to low. So this is the input signal, and considering this is the output signal, we have our propagation delay of 8.58 nanoseconds from high to low, and the delay of 24 nanoseconds from low to high. So that's about it.